All right, so the next tool that we're going to talk about is Deep Blue CLI. We've talked about how we can do these things by hand, right? Like what are the different commands that you could run on Linux? What are the different commands that you can run on Windows? But what are the tools that you can use that'll automate this process? Now, this particular lab becomes a feeder lab for the next lab where we're going to use it, which is the Enterprise Log Analysis Lab. Many people, when taking this class, ask a consistent question. All this stuff is great. How do I do analysis across an Active Directory environment? And the answer to that question is usually UEBA. That's what we talk about in one of the other classes. But for this course, we talk about it in terms of triage and how we can look at logs to identify a number of different shady behaviors. And the tool we use is by Eric Conrad, fantastic tool called Deep Blue CLI. I got to get my cursor up. There we go. There you go. Now, this is really cool. And the reason why it's really cool is it's kind of a UEBA, user entity behavioral analytics tool that you can use on triage. If you believe that a domain is compromised, you can have the organization send you the event logs from the domain controller, and then you can start running Deep Blue CLI against those event logs. Or the other thing that you could do is you could take a system that you believe to be compromised. If you have proper logging and alerting enabled, like command line logging, PowerShell logging, possible sysmon logging, and you can run it against those logs as well to get a really good in-depth understanding of what is happening on that system from a triage perspective. So here's an example of an alert that Deep Blue CLI gave me. And then I sat down and I wrote up some PowerShell real quick to investigate the event logs to see the logs themselves. So you can see I did get win event, filter hash table, give it a path to the log file, focused in on event ID 4672, piped it through some little like where queries where the object property matches Bertha Schultz. And what you can see is the Bertha Schultz user account is trying to authenticate to multiple different accounts very, very quickly. Right? Now, Deep Blue CLI, as cool as it is, has also migrated into Deep White CLI, which incorporates sysmon event logs, which is something we talk about in the Intro to Security class as well, which gives us a lot more robust visibility into the Windows system itself. So that's going to take us right up to the first lab of the day, because I warned you. We've got all kinds of labs going on in this class, lots of labs. So we're going to do the Deep Blue CLI lab. Now in this lab, you're going to CD into intro labs. You're going to open up a PowerShell command prompt first. CD into intro labs. You're going to open up Deep Blue CLI, set the execution policy to be unrestricted. You're going to hit yes. Then you're going to run it against some event logs that come shipped with Deep Blue CLI. These are great. They're built in. It's awesome. We're going to pivot a little bit later, and we're going to focus on enterprise log analysis from domain controllers, where you can see large scale attacks and how tools like Deep Blue CLI and UEBA can be very helpful in detecting those types of attacks as well. You're going to be looking at password spraying, password guessing. You're going to be looking at new users, and also a variety of different encoding techniques that attackers use all the time to bypass your products. Now, for this particular lab, I'm going to give us about, let's go just do 15 minutes. This is a pretty quick lab. You're literally copying and pasting and running commands, and literally Deep Blue CLI, just getting started is what takes the longest, and getting the VM set up takes the longest. So let's set the timer and we will resume at 20 after. 15 minutes for this one, and then we'll go through and walk through what we did in the lab. I'll see you in 15 minutes. All right, so let's go through this lab real quick. So as I said, we're going to open up a PowerShell command prompt, and we're going to go into the intro labs directory. So we got that. Yeah, there we go. And we open up PowerShell. Takes a few moments for PowerShell to load. There we go. Looking good. I'm going to paste that in. CD in intro labs works just fine. You don't need to put a C colon in front of it because you're already in the C drive. So if you're ever like, oh, well, it should be C colon for, no, not necessarily. So / works like an absolute champ because it's implied that you're going into that particular drive loader. I'm also going to CD into Deep Blue CLI master. I'm going to kind of show you around a little bit, but we're going to go into Deep Blue CLI, which is in the intro labs directory. Then we're going to set the execution policy unrestricted, just so we can run these scripts, because it is a PowerShell script. We're going to do yes. Let's go do yes to all. Let's live dangerously. Let's hit the A, right? A. All right. Then we're going to run it against the new user security EDTX file. Come on. Copy and paste is failing me. Stop. Stop, computer. There we go. That's what we're looking for. All right. We're going to right click copy. Paste that in. There we go. And it's going to take a couple of seconds. So whenever it runs, you can see that we had some new users added to the administrator group, which is kind of a bit crazy. But do you see what actually like happened here though? Like, look at this user SID, right? It's kind of weird. It's the same SID, right? It's the internet user account, which is a value of 1,000, which is actually the first user account that's created on a system. The first one is RID 500, that's administrator. 501 is the guest account. By the way, when I'm mentioning the RID, it's this last number right here. And then after that, it jumps to 1,000, 1001. But this one also was added to the administrator group, right? We can say that this user was created, which is normal, but then it was added to the administrator group, and notice the username, right? Notice the username is a dash. That's not right. So you can see that the username changed its name, right? And you can see it was added to the local administrator group. So this is one of those tricks where the attacker is trying to hide that user account on this particular system. Next, we can do password guessing. Password guessing is very, very different than a password spray. Password guessing is where the attacker attempts to try a whole bunch of passwords against one user account. And in this particular situation, it is the user account for the administrator on the system. And that's kind of makes sense. So let me explain why. The first reason why it makes sense is in most accounts on Windows environments, if I try to log in a whole bunch of different times, how many failed login attempts do I get before that account is locked, right? Think about that. How many? In many, many, many environments, it's like 3 or 5. It's usually like 10, right? Somewhere less than 10. However, the local administrator account on many Windows systems, the overwhelming majority of them, cannot be locked out. So it becomes a really, really good account to attempt to do a password spray or brute force password attack against, because it's not going to get locked out. Now, in many environments, they'll use something like LAPS and from Microsoft, which allows you to randomize the local administrator password on all of the systems. And that's very, very, very helpful. But we don't see that on every single environment. The other thing that this tells me is the attacker is more than likely attempting to gain access to the administrator account over RDP or sitting down at the keyboard. How would I know that? You cannot log into the local administrator account usually over straight SMB RPC. So it has to be done at the local system unless there's some group policy shenanigans that happen on it as well. Next one, let's go to a password spray. Password spray is very, very different. Very, very different than password guessing. With a password spray, we're attempting a single password against multiple user accounts. So Deep Blue CLI is smart enough to come back and say, look, you can see that we have somebody that's been trying to authenticate. The JWrite account is attempting to authenticate from the desktop JR78RLP, and it's attempting to log into all of the above user accounts that were there, right? So we can see that in this log, and it's really cool because there's no simple, easy way to just look at one event log and identify that somebody is attempting a password spray attack. It requires you to look at multiple event logs in context and conjunction with each other to be able to identify what they mean. So brute force generally means I'm attempting to gain access to a single account. When we're talking about a spray, usually a spray is where I'm attempting one password against thousands or hundreds of thousands of user accounts. And the other reason why an attacker would do this is because it allows them to go underneath that account lockout threshold of like 3, 5, or 10. Now, the next one is really cool. The next one requires there to be command line or PowerShell logging, preferably both, enabled on a system, right? If we have command line or PowerShell logging enabled on a computer system, we can look at what the command was. Now, if you remember yesterday, when we were playing around with the command line, we did WMIC get command line, and we were looking at our malware and we saw this huge amount of PowerShell that was in that WMIC database where we could query it out and see the command line that was generated for it. Well, it turns out there's a lot of ways to do obfuscation. And with Deep Blue CLI, it does some really cool analysis to attempt to see if obfuscation is being used. So this first one, it says there's only 60% alphanumeric and common symbols. You can see that we're using upper and lowercase and all kinds of weird like spacing to get around an EDR. The next one is a lot of fun. It's got a tremendous amount of white space at the front of it. Now, what the attacker is attempting to do there is kind of make it so the attack is outside of the bounds of the buffer for whatever tool is doing the analysis in the attempts to try and make it so it's not detected. If I scroll down far enough, you can see it starts to run. The next one, we're taking each individual character. If you remember when I was playing around with Netcat, I was looking at TCP dump data, and the hexadecimal data for A, capital A, was hexadecimal 4.1, right? B was 4.2, and so on. Turns out you can encode your commands by using individual characters, using a variety of different encodings, excuse me, in the effort to try to bypass these different tools, EDRs and SIM. So we're attempting the characters, and then we get to like, I don't know. It's just encoding. It's a crazy amount of encoding. That's pretty crazy, right? Now, I've been doing security for a long time, and I'm sure if I ever got the gumption, I could figure out what type of encoding this is. I'm just gonna be honest, it makes me want to cry a little bit. That's crazy. But your computer can read that, right? Doesn't work in just ASCII, folks. We have the same type of characters. Instead of doing each individual character, we're loading it into an array. And then we have some base 64 encoding here. And we should be able to take our base 64 data and we could throw it in something like CyberChef. And then you could do some analysis on it. So let's try that. See if CyberChef deals with this properly. So let me open that up. Maybe. Here we go. So this is my CyberChef hat. Go to CyberChef, paste it in, and then we can use a recipe from base 64. Yep, and it's got more encoding underneath it too, which is very common as well. You have encoding nested within encoding, and encoding its turtles all the way down, man. So we can try to deal with that encoding. So that's fun, right? But this shows a number of ways that an attacker can try to use different types of encodings in an effort to try to bypass your security products that are out there. Now, this next lab is a lot of fun. This particular lab, we're going to set up with server analysis, and if you're looking at the backdoors and breaches lab. Hold on a second. Brain's not working. Caffeinated. All right. That's better. All right. So if you're looking at server analysis and backdoors and breaches, this is a general purpose card that I created for the game. Server analysis fits for Exchange servers. It works for IIS servers. It works for Oracle database servers. It works for different types of devices that can exist on your network. But there's a problem with this if you're a SOC analyst and you're trying to identify what are the servers that are being used. And the reason for this is every single different service and server that you're working with has different security settings. Some of those different security settings will be in the form of a GUI. Some of them will be in a flat file. The log files that come off of those different servers and services will be different for every single one of them. And there's no one way to try to analyze those logs. It's actually kind of difficult. And many SOC analysts rely completely on their event logging analysis SIM tool to be able to identify what is actually happening on that particular computer system with the logs. Problem is, SIM log analysis maybe don't parse the logs the way that you want to. Maybe you're going from that data, information, knowledge pyramid, and you're really just stuck at data and you're waiting for some magical tool to do it for you. So if you're looking here, we've got web logs, right? We've got access logs. It's giving us access log data. And in here, you can absolutely see some attacks against this particular web server. I can also look at error logs. Once again, for an Apache web server, that we can see someone is attempting a number of different attack methodologies against this PHP server that's running on this particular computer system. But here's the problem that a lot of you run into, right? And we'll talk about this a little bit more during the Ask Me Anything. You try to apply for a job, okay? And I got a question for you, something to think about. If you're taking this and you're doing this video and you're running it through on demand, how many times do you spend looking at your resume, trying to figure out if you have the right thing on your resume? Do I have the right data on my resume? Am I missing things on my resume? And then you go to an interview, and as soon as you get into the interview, they're like, oh, yeah, oh, you're using Lima Charlie. Yeah, we use Elastic here. Or, oh, I can see that you have, some experience working with Saracata. We're a snort shop here. Yeah. Or you have experience with .NET. We use PHP. Sorry, you're going to have to go on someplace else, right? And you feel like you have to get to the point that you know everything. Or you may be even like, how come I'm not getting interviews? Trust me, a lot of companies are looking for these really wonderful unicorns that just don't exist. They're going to go through all the resumes and they're going to look at the technologies that are listed on those resumes. And if you don't have anything mentioning the technology stack that that company is using, they don't want to talk to you, right? That's what's going on. There are jobs in computer security, but organizations are being very discerning about the people that they're even going to interview and even more discerning about who they're going to hire. Well, turns out we can, let me go past the auth log. Turns out you can look at what that company is using in their technology stack, and you can go to the CIS benchmark guides and you can start learning that technology stack. Maybe you can start going through and doing investigation, installing the open source or trial versions of the software, going through the CIS guides so that you can understand where the security relevant features are and how to access those features for the relevant technologies that you are investigating. Like, where are the logs, right? Where are the users? Where's the security settings for encryption? Where are the passwords stored? Where are the permissions stored? The CIS guides are literally some of the, or not just CIS guides, the NSA SNAT guides, CIS guides, the SANS hardening guides. These are the things that jump-started my career in information security. They jump-started my career because I was able to look at the technology stack that the organization that I worked at the time was using, and I could go through these guides and I learned where the security relevant settings were for each one of the technologies that we were using in that organization. In this case, the Department of Interior, right? They were using Oracle. Awesome. I've got the Oracle hardening guide. I stand up an Oracle database and I start going through and learning all the security relevant settings for Oracle. I would go into a meeting, and that meeting, people would be like, my God, this guy's an Infosec Tyrannosaurus Rex. I just read the freaking manual. This is a cheat code for you, right? And we always joke about this as RTFM, read the fine manual. And when you're applying for a job, if you see a company, don't just give them your resume. Go investigate what technologies they're using. Pull down the CIS guides, get familiar with that technology, and make sure it's right up top on the top of your resume saying, I am familiar with OpenVPN. I am familiar with Fortinet firewalls. I am familiar with Saracata. I am familiar with Snort. I'm familiar with Windows. I'm familiar with Linux. I'm not asking you to lie. You should never, ever, ever lie. But if you get into an interview with me and I say, these are the technologies that I need to have, and you can answer some questions rather intelligently, and you tell me, look, I sat down, I stayed at a Holiday Inn Express last night, and I sat down and I just started going through all the technologies that you were using. I pulled down all the guides, found out where the security relevant settings were. That's actually more important to me than you being adept in those technologies because it shows me that you can learn. You can dig on your own and deal with your own problems. So I'm going to give you an example walkthrough. I just pulled one at random. Now, it's not like everybody is using PostgreSQL, right? I don't want to try to get that across. It's just this is an example. And then the lab that we're going to do is we're going to do log analysis from a Cisco Adaptive Security appliance. It shouldn't see these things anymore, but you see them all the time. And I added it into the class because I freaking hate them. I don't like their logs. I don't like doing log analysis on them, but I'm going to show you some techniques that you can use on every single log output that you get that will help you be able to address and adjudicate those logs to find potential malicious activity using those things as well. So this is just an example of using PostgreSQL. So the first one, let me zoom in over here for a couple of reasons. One, so you can see. So right here, it says the PostgreSQL runtime parameters that are executed by the postmaster process. Right there, I know that the postmaster process is important. And we have select star or select name settings from PG settings where context equals postmaster order by one. So these are all the permissions that I have with the postmaster service. And also look, it tells me the PG underscore settings is an important table. So if I look at that particular table, I now, when I'm doing an interview, if people are like, oh, you have to secure a Postgres database, where would you start? You basically be like, a lot of the really relevant security settings are in a table called PG settings. And then be honest, I haven't memorized everything in PG settings. I just know that I want to pull that data from that PG settings database table to do analysis. Here's another one. What is this one? It is backend runtime parameters are configured properly. Excellent. So now I can see if there's debugging support, profiling support, long connections, and how I can actually set up authentication delays to try to secure that as well. Awesome. This is all just reading the manual. We got more. What is this one? Oh, the user. So in the guide, it says, who am I in Postgres? And I can start PostgreSQL and I can log into the PostgreSQL account with the Postgres account. I know it seems weird. And then I can check and see the roles, right? Postgres has super user, create role, create database, replication, and bypass RLS. That means that particular user account is the single most important and powerful account in the Postgres database. So if somebody was asking me, you got to secure PostgreSQL, I would say, look, I would first make sure that the web server isn't running with full Postgres access, which is full DB administrator access to everything. The web server should have broken out different roles for the different responsibilities and the permissions that are required for the web server to run properly. And then I can see I've got an app user. And look at this as an example. We have app user has the exact same permissions as the Postgres account. So that means I now know I can audit that specific account, but I can actually go deeper and see if any other accounts have those roles as well. Ports and services. Here's a good security relevant configuration setting, right? So if I look at this, I can pull down primary connection info, replication user, password is my password, but I can also see if SSL is enabled. And this gets to audit and compliance. If you're working in audit and compliance, one of those things that they're constantly saying is all data should be sent encrypted. And you can find out that it's SSL mode equals required, and you can choose your different SSL cipher settings, right? Now, I can play around with these, stand up my own PostgreSQL database, go through each one of these settings, run these queries that they're giving me, and now I'm pretty familiar with PostgreSQL. Now you may ask, how effective is this? One of the groups that I've done work with is IONS. And it's kind of like the Infosec Avengers, right? There's a bunch of people in IONS that are amazing security researchers, and we get a lot of really off-the-wall questions. And one of the things I loved while I was still doing Ask the Experts with IONS is I loved somebody asking me a question about a tool or a product. I didn't know anything about it. And I'm like, you know what? I'll take that call. And I would spend the time looking at their question, and I would learn by reading the documents, standing up the thing, spend a few moments trying to learn where their question is answered. And then I would get on a call with them. They would ask me the question, and I would say, oh, it's in this configuration setting at this particular point. This is where you find it. And they would be amazed. They would just be like, how did IANS is the name of it. They'd be like, oh my God, how did you know this? Like you're some kind of super genius. Literally, the only thing I did was RTFM. I just read the fine manual and it worked, right? Works really, really, really well. So now we're going to get into that lab, and this lab is going to take us up to and through the break and probably going to take us a full half an hour. So we're going to give it till 15 after. This lab takes a while mainly because we're installing some tools. So the lab that we're going to do is going to be the firewall log review, right? So one of the problems that you're going to run into as a SOC analyst is you're going to have some janky technology, some ancient technology, some weird technology, and they're like, we think we're hacked. And they're going to give you the logs from that tool, that service, or that server, and you're going to have to parse it. And that's the goal of this lab. So we're going to be using our Kali system for this lab. And as I said, it takes a few moments to get everything installed, but once it gets installed, it goes pretty fast. So I'm going to go ahead, and the first thing I'm going to do is I'm going to become root, like so. And then I'm going to install the RBase core libraries. This allows your command prompt in Bash to be able to do math, statistical analysis. You could also use data mash as an alternative that allows you to do that as well. So we're going to install the RBase tools on your Kali system, and then we're going to use those tools to do analysis of a firewall log. Now, the goal of this log is to get you familiar with like grep and using cut to find specific offset and fields so you can drill in on the data, because as I said, these log files from Cisco ASA are nuts because the way it actually displays the log data changes based on what it's logging. So it's not as simple as just doing columns and saying this column is X, this column is Y, this column is Z, because X, Y, and Z will be different based on the type of thing that it is logging. So we're going to show you how you can use grep to search for a specific string and only pull out the lines that match the string that is interesting to you, or with V, the inverse. We're looking at data that like data lines that I want to exclude. So we were sitting here in the 24, 230, 56.6. I want to grep any line that doesn't have that string. We're cleaning and refining the data. So you're going to work through clean and refine this data, focusing in on specific column fields, and we're going to eventually get to the point where we're doing full mathematics against those particular fields. Because when we're doing server analysis, when we're doing application analysis, it can be really hard to be able to address those log files if you don't know how to use things like cut and grep. All right, so that is the lab. Let's get rolling. It's going to take 30 minutes, and then I will do the walkthrough at the end. See you on the other side. All right, so as I said, the goal of this lab isn't like, hey, here's how you find a beacon in an ASA firewall log, but rather the goal of this is what are the tools and techniques that we can use to analyze almost any log file that we would be ingesting. So once again, with my SOC analyst, we may have a customer that has some kind of weird, obscure appliance, and they're like, we want to know if there's a compromise here. And then we've got to parse the logs, or we got to look at firewall logs that maybe we aren't getting ingested into our SIEM yet, or a web server that wasn't basically sending us telemetry, and now we've got to do investigation. So it's very common to do this type of analysis, or at least have the capability to do this type of analysis. Now, before we got started, I went through the first steps. I became root and I installed the RBase core. So now we're going to pick up right from that point, and I'm going to CD into the opt firewall log. And then we're going to start with some basic analysis of the firewall log itself. Now, I'm going to start right here with this particular command, and I'm going to give you kind of a narrative that's very, very common, right? One of the narratives that we see a lot in our customers is we have an IP address that's exhibiting odd behaviors, right? Like somebody's sitting at that computer and it's popping up the Cookie Monster, and he's like, me want cookie. And he's like eating the desktop, chomp, chomp, chomp. And what do you do when you encounter a Cookie Monster virus, right? Like, how do you deal with that? I know that that IP address is 192.168.1.6, but how do we stop the Cookie Monster virus? You should Google How does one stop the Cookie Monster virus? But the first thing I would do is I would go to my firewall and I would try to see if I have the logs for that specific system for its traffic going to the internet. So let's go ahead. That is not at all what I wanted it to do. Let me do this, do that. And then we'll do space, space, space. There we go. And I'm just going to see if I have the logs at the edge of my perimeter for the system that is in question, right? So I hit enter. Sure enough, I've got logs. Awesome. And grep is cool enough that it actually color codes every single time it sees that 192.168.1.6 connection. But also in these logs, I see a lot of data for this IP address. This 24.30, 230.56.6. Right here, I see 1, 2, 3, 4 different log entries for that specific outside IP address. Now, if I do a little bit of digging, I quickly find out that that is the edge router, right? That is the edge of my network. And I also know by doing some quick analysis that I do not care about any of the logs that are going to 24.230.56.6, because that would mean the attacker had compromised my edge router. More than likely, although that is possible, more than likely that is not at all what is actually happening with this. So if I'm analyzing, I'm using grep to pull out specific logs, but I can also do grep to say, I want to see logs that do not have that IP address. So if you look closely, what we're doing is we're doing two greps. The first grep is pulling any log entry that has 192.168.1.6. And then the other one is saying, but ignore any line that's going to 24.230.56.6. So we're doing two separate grep statements, which once again, this is the point of the lab, right? These are the things that we are doing. How do we find lines that match certain patterns? And how do we ignore lines that match other patterns so that we can get to refined data to investigate what is happening in these logs? And when I do this, I see I have a whole bunch of connections. Once again, we've got our internal 192.168.1.6, but on the outside, I have all this traffic that's going to 13 and 18. We have 18.160.185. We have 13.107.237.38. And it's all HTTPS traffic going to these two. Now, the other thing I noticed whenever I'm going through these logs is I noticed that there's a lot of connections. It's not like one HTTP request and then synac, it's synac fin, synac, or it's actually synac ac fin, synac ac fin, synac ac fin. And what that is indicative of is beaconing type behavior. So I need to be able to investigate and identify what those IP addresses actually are. Now, did anybody do any investigation on these IP addresses? Like we can go check IPDB info. Now, these are kind of interesting. So let me do a check on that. Let's go. There's all kinds of websites out there that allow you to do that. Oh, geez. Of course, I used Bing. Let's just go to IPDB info. There we go. I cannot believe just how bad Bing is, right? So I can take and I can put in an IP address and let's do a quick check and see if there's any hits on it. All right, so this one's interesting. This one's Microsoft Corporation and it has a 0% risk. That's interesting. But it's going to their data center, web hosting, transit. Interesting. The next one that I have in there, that's the 13. Let's take a look at the 18 IP address here. I'm going to copy that. Paste that up over here. I mess up on that. Yep, I got a colon. There we go. This one is going to Amazon, and it's specifically their CDN. And if you're looking at this particular one, there's no real risk associated with this one as well. So I have two IP addresses. I have one IP address that is going to Microsoft, and I have another IP address that's going to Amazon. That's interesting. Let's dig deeper. All right, so now I want to start looking at those specific connections, but I'm going to now grep any of the lines that have fin, which means that's the end of the TCP connection. And then I'm also going to run that through cut, and I'm going to identify my delimiters as a space right here. So that is my delimiter where I'm identifying it as a space. And then I'm going to say I want to pull the fields and the columns 1, 3, 4, 5. This allows me to identify exactly which columns are of interest to me for doing the analysis on this traffic. So we're going to focus in on the, which one are we going to focus in on? Well, let's just pull out those fields first. So I'm going to copy that, and then I'm going to paste that in here. There we go. And I'm going to hit enter. Ooh, now we're getting some delicious data. We're getting some really cool stuff at this point. So we can see that we have a teardown connection for outside 18 160.185.174, and then another one right after it's going to 13, and then another one's going to 18, and another one's going to 14. So it's literally Amazon, Microsoft, Amazon, Microsoft, Amazon, Microsoft. That's weird. Why are they like super working with each other? That seems weird. Microsoft and Amazon have decided to like conspire against me. But if I'm looking at these data sets, you can see the teardown connection. Look how fast that beacon is. Like it's literally a 1 second duration. 1 second. And we're also looking at the data size. That's also very interesting. So we're going to be looking at that in some more data as well. So now I can actually look in on a specific IP address. In this situation, we're looking at the 13 IP address. I've got those. We're going to right click, copy. Let's paste it in. Control L to clear my screen. Hit enter. Now I'm just looking at one. I'm not looking at 18 and 13 where they're bouncing back and forth between them. Now I'm just looking at one. In this particular situation, you can see that the number of bytes that are transferred are very, very, very consistent, very close to each other. We've got some good patterns that we're seeing in that data, and I'll show you what that looks like here in a moment. So we can look at that in a little bit more detail. Same thing, but looking at 18. Copy. Paste that in, hit enter. And 18 also has a very tight connection profile, right? So if we're looking at it, we've got 1816, 1816, 1832, 1816, 1816, 1848. Really, really tight profile on that. But using the magic tools that we're talking about here in this lab, we can now start focusing on just a specific field. For example, I can look at just the field that has the data size. So instead of it showing absolutely everything, it's just that one column. Which once again, this is the question. This is what we're trying to get out of this lab. How do you take this data in form of logs from a specific type of system and start analyzing it? Because once again, the goal of this lab is not how do you find a beacon in an adaptive security appliance from Cisco. That's dumb. But the goal of this lab is to show you how we can use grep, how we can use cut, how we can use our tools to take that data, convert it into information. Because right now I've got good information. I've got a really strong cluster pattern of data sizes on that. And then I can turn that into full-on knowledge, right? So I can take this and I can do some, let's do some fancy math on it. There we go. And we're running it through our tools. Now, what we're doing is we're kicking it through our script, and it's just going to do some basic statistic analysis. It's going to receive the data from standard in, and it's going to give us the minimum value, the maximum value, the mean while, and the standard mean y value, the standard deviation, and the variance. So let's go ahead and hit enter. It's going to answer those three questions for us. The minimum value is 1816. The maximum is 1848. The mean is 1829. The standard deviation is only 12. So it's very, very, very tight in that data set. And this is giving me knowledge that I'm probably dealing with some type of beacon where it's beaconing out. Now, let's go do Paul Harvey's the rest of the story. I was given this packet capture by my security team. They created a packet capture on an ASA that we had here where they created the malware. This was malware. This was custom malware that we created at Black Hills Information Security that alternated its beacons bouncing off Microsoft's content delivery network and Amazon's content delivery network. And the reason why we do that is because if you looked at the security score for those two different IP addresses, very low risk score. One was just Microsoft Data Center for CDNs, and the other one was Amazon's CloudFront CDNs. The vast majority of SOC analysts, if they were to investigate strictly based on the IP address and the reputation of the IP address, they would basically say nothing to see here and they'd move on. And they would be compromised by an adversary that's running at about a nation state level adversary, like a team level attack. See, some of the questions that I've been seeing, right? And some of the things that keep coming up is people saying, well, my tool will automatically do this, right? If I have a beacon in SOAR, would it detect this? No, it would not. Unless you're running AC Hunter. AC Hunter absolutely would detect this, and we'll talk about that more later, but it's the only tool that would detect something like this, right? So this requires us to have the ability to be able to dig deeper, because far too many SOC analysts rely exclusively based on what their tool tells them. And you can do that. You absolutely can do that. That is well within your prerogative to learn how to use tools, get good at those tools, and just run those tools. But you know what? You're the first in line to be laid off with AI. You're the first line to be laid off as they're doing security orchestration automation and doing deeper level activities. So if you're okay with just doing what the automated tool does, then you have to be okay with being replaced by that automated tool at some point in the future. Because to be honest, the automated tools work. They work really, really, really well for basic level ransomware, Skidiot level attacks. They do not work at all dealing with nation level attacks coming against your organization. And if you want to have job security and you want to get your foot in that front door and you want to be able to get that interview and you want to rock that interview and you want to make it through whatever economic and tech downturn is coming, you better know how to do the things that I just did, because this isn't advanced. This is table stakes. This is step level one. And unfortunately for the industry as it is right now, the people that are hiring aren't looking for junior level analysts that have a lot of heart and they're willing to learn and work hard. They're looking for people that understand these basic level skills that are out there today. So if you're looking at this and you're like, yeah, but the tool will just do it for me. That's great. But you're this close to being replaced by a tool. So, all right. So I know that that's some kind of harsh. I apologize for that, but I would much rather we have some honesty in talking about what's going on in the industry than having people continue to keep just trying to update their resume's font to get the job, because that's not going to work. All right. Let's move into another thing that a vast majority of people do not understand how to do. And you're going to see why this is so incredibly powerful here in a couple of seconds. So I'm going to set up a scenario. You have a system that you believe to be compromised, say possibly by a nation state level adversary, right? And that server is running in the cloud, right? It can be running in Azure, it can be running in Amazon, you can run it in VMware. You have a number of places where you can have that virtualized asset that exists. But you think you have a nation state level adversary and you think they're really good. And as soon as you get on that system and you start running security tools, they're going to know that you're there and they're going to get spooked and they're going to run. How do you detect those attackers? Same thing as we're moving forward into the future. More and more corporate organizations are going to have VDIs, where it's going to be virtualized desktop environments that you're going to log into your Windows system in the cloud that is automatically provisioned for you in Azure, right? How do you deal with doing analysis on those particular computer systems to detect malware, to detect lateral movement? Well, it turns out we can answer that question. And we can answer that question through memory analysis. And for a long time, memory analysis was an absolute nightmare. Data acquisition was difficult. Formats were difficult. Trying to get tools to get the symbol lookup tables was incredibly difficult. And I'll explain what those are in a couple of seconds. But basically, it's a roadmap on where to find things in memory files. So we have a tool that we use in this industry called volatility. It is without question my favorite, probably the main memory analysis tool that's out there today. And you can pull memory off of systems by doing a snapshot in things like VMware. If you just snapshot the virtual machine, there's a suspended state or a snapshot file. Volatility can mount that memory snapshot and do analysis, and the attacker will never know that you're on to them. They'll never know that you're starting to investigate what's going on. So this is one of the most important, powerful techniques that hardly anybody knows and understands. But when we're working incidents, we're dealing with servers, I don't want the attackers to know that I'm on. So I'll dump that memory off of that virtualized server. I'll dump that memory off of that workstation using WinPMEM or a number of different tools. And then I can do this type of magic. For example, I can do NetScan. This should look familiar, because the exact same methodology that we did with Windows, where we're looking at network connections, investigating processes, looking again at network connections, process execution, parenting, and hierarchy, we can do all of that with volatility, with dead memory of a computer system to do that investigation. If you're working an investigation and you have a notebook or a desktop that you think is compromised, and your first step is to isolate, neutralize, and shut down that system, one of the things you should do is do memory analysis, where you dump the memory off the computer, then take it off the network, because then you'll be able to do that network analysis after the fact. Processes. We have the process ID and the parent process ID. What process begat which other process on this particular computer system? Memory analysis DLL command line. Remember, we went taskless /m /fi, where we created a filter. And then within that filter, we did PID, EQ, the process ID. We can do all of that with volatility. Same thing. We can give it a memory dump file. We're going to give it a DLL list, and we're going to give it a process ID. It'll give me the command line invocation and all of the dynamic link libraries that are loaded on that particular executable. So if this starts to look like we're repeating network, process, command line, parentage processes, it's because it's a methodology. It's a process that every single one of the people that are going into this industry needs to have these types of capabilities to be able to deal with incidents properly. So that brings us to yet another lab. All right, so this lab is going to take a while. And the main reason why it's going to take a while is because your systems are going to go back out to the internet, and they're going to download the kind of symbol lookup tables for this. So I'm going to walk through the first few steps. Once again, we're running in Kali. I'm already running as root. So I'm going to CD into the opt volatility 3 directory. And then I'm going to kick off the first volatility thing, because it takes a little while for it to run, but we can run malfind. Now, malfind is really this quick, dirty look at the memory to identify if there's any potential malware in this particular memdump file. And it takes volatility a while, because it's going out to Microsoft. It's pulling down the symbol lookup tables where the directionality is for different things that exist on this system, like where are the network connections, where are the process connections, and it's going to pull all that down, and it takes a little bit. So be patient. So this lab is going to take us up to and through the next break. We will resume at 10 after, and you're going to see my screen do things, by the way. Bad things. But I'm just pre-running the stuff so I can walk through it faster when we do the walkthrough. So it takes a little while for it to run. So be patient. So let's jump into it. If you need any help, let us know. Remember, be patient. It can take a little while. All right. So let's go through this lab. As I said, with this particular lab, I kind of jumped ahead a little bit. And I pre-ran the commands because, as you saw, it takes a long time. Now, why does it take a long time? What exactly is going on in the background? Well, whenever you're looking at Windows memory, like map files, different operating systems will map the locations of things like process information and network connection information in different offsets and different locations. That's an oversimplification, but it gets you the idea. And this isn't just something as simple as like Windows or Linux. It's literally down to the version of Windows, the service pack, and the language pack. So having that type of mapping is actually a far more complicated endeavor than just saying, oh, Windows, it's here. So it has to reach out, pull that information down so it knows where the right place is to look. So when you're running volatility initially against a memory dump file, it identifies the memory dump file, gets the operating system version, and then it starts going through and pulling down the proper mapping for that specific version and build of Windows. Now, the first one that I had you ran was Malfind. Malfind is an absolute smoke test. Like, we want to go into a memory dump of a system. We think it's compromised. We don't want to let the attackers know that we're on to them. We do a snapshot of that virtual machine or that cloud-based instance. Then we pull that memory analysis down, and the first thing we run is Malfind. Now, Malfind doesn't, it's not like a enterprise grade EDR that's like, oh, well, here's the malware every single time. But it's a really good first check. And in this particular situation, if we're looking at the memory pages, it's looking for pages that have a memory setup of read, write, and execute. Usually when you're looking at memory, it's readable, or it's writable, or it's executable. Very rarely do we see it read, write, and execute all at the exact same time. And out of the gate, it caught trustme.exe. It's like, yeah, that's a read, write, execute. That's kind of something you want to look at. And it gives us a little bit more information about the stack associated with that executable as well. So you can see trust me shows up multiple times. This is one of those weird things about doing memory analysis. A lot of the data structures and data that's stored in memory analysis is repeated in multiple locations. So if you're looking at network connections, it's very common for there to be the same thing repeated in that memory dump files 3, 4, sometimes 5 times. So you see this repeated multiple times. The other thing that I really like about this lab is it shows you that, yeah, that malware is doing read, write, execute, but then we also have something like Search UI that does the exact same thing. Now, to my knowledge, the system that I ran this particular attack and this malware on, it didn't compromise Search UI. It just exhibited a lot of the exact same behaviors as what we see in malware. This is probably in the category of a detection tuning opportunity or a false positive, if you will. Right? So now I want to run NetScan and I want to look at the network connections. Now, by and large, you're going to focus on the network connections that are established, or you can also look at SYN sent or closed. The reason why you want to look at SYN sent and closed is Microsoft is very bad at cleaning up after itself. Whenever a process is reestablishing a network connection or a process dies, it is very common for that process connection information to reside in memory longer than it should. Usually you would expect a process connection to die and then immediately it would be removed from all vestiges of memory and anywhere. That's not how it works. So you'll see things repeat again and again and again, and you'll actually get information that's contradictory to each other. So in this, you're going to see that there's a closed connection that is interesting, and then there's also a SYN sent connection. So I'm scrolling down. I want to look for established, closed, SYN sent. Lots of listening. Here we go. This is our trustme.exe. So you can see trustme.exe is communicating between these two computer systems. 192.168.192.145 is communicating out to the internet on 172.104.59.60. And I think that that's DigitalOcean. I'm not sure if I set it up. I either set it up on DigitalOcean or I set it up in Linode. I can't remember where I put it, but it gives me a little bit of something that I can start investigating. I set it up in Linode. So sure enough, we have that connection that's going to a Linode instance, right? So let's go ahead and let's keep scrolling down and see if there's other interesting connections. We've got listening, listening, listening. I'm really focusing on those established and closed and SYN sent connections. And oh my word, right here, look at this. For me doing a forensics analysis, if I'm a SOC analyst, I'm investigating the system, I see that closed connection, I see the SYN sent connection out to Linode, but at the exact same time, I have this potentially suspect trustme.exe executable. I have a simultaneous connection On the inside of the environment from 192.168.192.145, that is making a connection to 146. Dum, 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 the plot thickens. This is an SMB session. So I have a system that's exhibiting malware, and it's also pivoting and accessing another workstation. Now, look at that particular process ID. This is interesting. Notice how that process ID is 4. It is not 5452 like trustme.exe. This is a strange oddity about Windows. In Windows, if you're ever doing an investigation, if you have a connection between one Windows system to another Windows system, it's not going to be done by the executable itself. It's going to be done by the systems process, which is real creepy. Very, very difficult to try to trace some of this stuff down. You'll see the process hierarchy here in just a second. But anytime that there's a remote share that is mounted on another computer system, it's going to show up as the systems process. All right, I can scroll down a little bit more. You're going to see those repeat here a couple of times. But once again, there's that SYN sent right over here. Look at it. We've got SYN sent. We've got it just as that system beacon. It closed that connection and then reestablished that connection. And we caught it right in between, which is pretty cool. We also see some connections from chrome.exe as well, which of course is how I compromised the system in the first place. So let me scroll down and let's do some more investigation, but let's switch into the processes here in just a few moments. So now we're going to do PS list. So we're really going to be focusing on that trustme.exe executable and looking at all the processes associated with that trustme.exe executable as well. Let me scroll down. I think it's pretty close to the bottom. And there's our Chrome. There we go. Here's trustme.exe. All right. So this is kind of cool. So I'm going to put trustme.exe right there at the top. So we can see that trustme.exe has a process ID of 5456. It was invoked by 3616, which I think is Explorer. But then 5452 invoked cmd.exe. You can see that it started that right there. 5528 is cmd.exe, and that invoked the con host executable, connection host, which also invoked the cmd executable. So you can see that cmd.exe was invoked on this system. They ran the net command, which invoked con host, which invoked the system process from making a connection on the other side. Now, don't panic about this, all right? So a couple of quick notes about this, because it's just like, what the hell? So this stuff isn't necessarily something that you can have a class that teaches you all of these different things. I've been doing this now for 25 years. That's a quarter of a century. It's longer than some of you have been alive, right? So this is stuff that you pick up all the time, right? This is stuff that you pick up over time. So if I'm looking at this process ID is the parent process ID for command.exe, and then command.exe 5528 is the parent process for both connection host and then the net command on that system. That's telling me these connections work. So here's what I'm going to give you as a recommendation. You're going to be doing this type of PS tree process hierarchy analysis as part of your job, but you're going to be developing theories about what is happening on that particular computer system. And it's going to be incumbent upon you to investigate those theories. And one of the best things you can do is try to recreate your theory in a lab environment, especially if you ever plan on going to court. Just some of the stuff that I do. All right. So here you can see it laid out a little bit cleaner. Let me zoom down just a hair more. There we go. So we've got trustme.exe begat cmd.exe, which started conhost and the net command right there. And you can see as these little dots, like the stars, this star begat this star begat this star, because it's showing us the layers. And then we have cmd.exe was the parent process for both the connection host and the net process on this particular computer system, which is pretty cool. All right, let's go down. doing this. Now let's dig in on that process ID. Do these dynamic link libraries look familiar to anybody? Yeah. Dynamic link libraries are the same ones that we saw in the Windows section, Windows CLI, right? So you're seeing these things kind of pop up as these themes, these chiasms that show up again and again and again on this. So we're literally showing you more than one way to do the exact same thing is basically where we're at with this. All right. So let's go ahead and let's get back into the slides. And now we're going to talk about egress traffic analysis. A lot of the environments that you work with will be running like perch sensors. They'll be running Fortinet. They'll be running possibly Zeek and some type of firewall. And you're going to have to do some type of egress traffic analysis. And this is kind of critical when you're looking at the MITRE attack technique matrix. It's an entire category called command and control and another one called exfiltration that you need to focus on and be familiar with the different techniques and how they work. But as we were going through that previous lab with the ASA, Adaptive Security Appliance Log, people are like, dude, I don't know, like it's neat that you can do this from Bash, but how do we do that at scale automatically instead of by hand? And once again, the goal of that lab isn't here's how you review a firewall log by hand. The goal is any log file, learning grep and cut and doing data analytics is absolutely key for everything that you're going to do. But it's still a valid question. How do we do that type of analysis at scale? This goes down to the desperate need for visibility for the network traffic that's going on in our environments. Absolute need, right? We can't just rely on signature-based detection because signature-based detection is many times not possible. Why? Because of encryption. If you're looking at most of the traffic on the internet, it's encrypted with SSL TLS. And that makes it difficult, if not impossible, to do simple signature-based detection looking for malware in packet captures. However, if we can look at the patterns within that traffic, maybe we can start identifying potentially malicious or at the very least non-human traffic in that packet capture as well. And this is one of those weird areas where Gartner and I absolutely agree with each other. I really believe that network visibility is crazy important. So editors, quick note. So yeah, I hit a bunch of slides in the slide deck. I kind of updated and did some different things. So if you go back and you look at the PowerPoint slides, there's a whole bunch of slides that are hidden. And I hit a bunch of those slides because we have them in the Intro to Security class. And I'm trying to spend more time on network, Windows, Linux. And I just kind of pushed some stuff over to the Intro to Security slides. So if it doesn't show up, your slide deck is different. Look, those slides are actually hidden. So they're still in the deck, but they're just suppressed so they don't show up. So hopefully that clears up a little bit of confusion on that for, what is it? Tricycle Rider. I had that question. All right. So editors, we're going to go back into it. All right. So as I said, even Gartner and I agree on this. And this is kind of one of those weird things that happens every blue moon, right? So what are the tools at our disposal that allow us to do network traffic analysis to get visibility into what is actually happening? One of the things that we can use is NetFlow. NetFlow is a collection of statistics very similar to what we just saw in the ASA logs. It's a standard from Cisco. The current version is NetFlow version 9, and it'll pull down the data from different devices that has traffic going through them. And you can have an exporter, that would be the device itself. An importer could be like a log analysis engine or a storage engine. And then an analysis engine would be your SIM, where it can analyze those network traffic logs with NetFlow version 9 to be able to identify those potentially malicious traffic patterns that are out there. Now, this is great. Cisco's got a standard. Unfortunately, there's a variety of different implementations that exist on how they're handling those logs and logging things like time. When did a connection start? Did it start officially at the beginning of the traffic? Did it log it as starting at the end? Sometimes it logs it in the middle, which is really, really weird. Now, we're going to be focusing on Zeek in this class. Zeek is very much an industry standard. It's an industry standard for some really good reasons. One, it's fast. really fast. You wouldn't believe how fast it is. It's freaky fast, right? Has a huge user base in the community, tons of support, and it has consistency. Now, when you're thinking of tools, a lot of people think of a tool that does automatic detection of malware or it has a fun GUI. Zeek has none of that. What Zeek does is it takes data from network packet captures or live data streams, and it breaks that data up into representative log files like DNS logs, HTTP logs, FTP logs, connection logs, SLS, TLS certificate information, SMB and Kerberos information. It literally takes a packet capture file and it breaks it down into the individual buckets that we would then investigate as separate, discrete log files. Now, what we're going to do here in a little bit is we're going to show you how we can pick up that data from Zeek, and then we can do analysis on it where we can start doing behavioral analysis to identify potentially malicious traffic patterns rather than just relying on signature pattern matching as well. So the heart of all the things that we're doing here is a tool called RITA, Real Intelligence Threat Analytics. And what RITA does is it picks up Zeek logs and it identifies non-human beaconing traffic. It'll identify that traffic and it'll alert you as to whether or not there's malicious or potentially malicious traffic, more accurately, non-human beaconing traffic. But it also has the capability of doing denialist checking, DNS views, long connection analysis, and it is free for everybody to use everywhere all the time. Now, how exactly does RITA do this? Well, if you remember, whenever we were looking through that Cisco ASA log, we saw a lot of things that RITA would be able to pick up on, right? The connection interval was 1 second, 1 second, 1 second, 1 second, 1 second, 1 second. Or the data size, very tightly clustered, very consistent data size. So what we're looking for here is very similar to some conversations that children have with their parents. I'm sure that you have been around children or been around people who've been around children that have had a conversation where the kid is going, mom, 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 over and over and over again. That is a beacon, right? It's very consistent in its interval. Mom, mom, mom. It's very consistent in its data size. MOM, MOM, or dad, 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 dad. DAD, DAD, DAD. It's very consistent in its connection time. It's a different way of looking at interval, but its connection time is also very, very, very quick. Now, whenever you're looking at perfection in those, you use algorithms like k-means clustering and MADMOM, medium average distribution of the mean. And what they're doing is they're looking for clusters. Imagine each of the white dots up here on the slide represents an individual connection. And we're analyzing those connections across multiple attributes: the interval, the data size, and the connection time. The more perfect and consistent they are, the closer it gets to the center of the flux capacitor that's upside down. It's kind of an anti-flux capacitor, right? So the closer it gets to the center, the closer it is to perfect. Even though we have a very consistent interval like mom, 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 there's little itty bitty variances, very minute, maybe milliseconds. Data size might be slightly off because of date timestamps, right? So it may not be perfect. So what we're focusing on is less trying to identify the absolutely perfect beacons, and instead we're looking for the clusters. So you can see that we have a cluster for interval, we have a cluster for data size, and we have a cluster for connection time as well. So the other thing that we can do is look at long connections. So I want you to think of, you got a day, it's over 86,000 seconds, right? So we have a day. And let's say that we have a really good attacker that understands the mom, 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 mom. They know that people are looking for those types of beacons. So what they're going to do is they're going to shatter their connections to make it so it's quote unquote pseudo random, because we can't really create perfect randomness with computers. Everything we do is more pseudo random in nature. So some of their connections will be 30 seconds. Some of them will be 5 seconds. Some of them will be 1. Some of them will be 1 minute. The attacker is going to start shattering their connections and greatly varying their connection intervals. Turns out with Rita, we can still detect that. So even if the attacker is trying to get really creative in what they're doing with their connection intervals, if we reassemble all of the connections, you'll still see that it adds up to like a day or multiple hours. So I want you to think of it as like a string. Uh-oh, did I get lost? Can you all hear me? Editors? I think I just lost connectivity. Okay, you can hear me? I just saw the O faces, like, and that's just like, uh-oh. All right, we're good on Zoom. Awesome, editors. We're going to go right back into it. All right, so the spaghetti analogy. I want you to think of a string of spaghetti, uncooked spaghetti, mom's spaghetti, because there's vomit on a sweater already. We have this string of spaghetti, and if I break that spaghetti, it's going to break into big pieces, little pieces, and it's going to shatter all over the place. But if I reassemble it, it's still going to be the same size as that spaghetti, which is a 24-hour period. So we can look at the connection intervals, and if they're randomized all over the place, but it actually adds up to a full 24 hours, well, that's something that I want to investigate as some weird stuff in that environment. Beacons, this is Rita's raw output. We're going to show you this in AC Hunter here in just a little bit. But if we're trying to figure out which beacons we want to focus on, we can deal with weighting. And in this particular weighting, you can see that we have the top two entries have a perfect beacon, which is really rare, by the way. We have a beacon of 1. So we have 192.168.88.2 is talking to 165.227.8815 and 216.194. But if we're going to try to figure out which ones we want to investigate first, let's talk about we just focus on the ones that have 108,000 connections, because that's a really strong beacon. Lots and lots and lots of connections. So even though there's a number of systems that have strong beacons, we only have a couple of systems that have thousands of connections that match that beacon profile as well. Now, when you do this, you're going to find all kinds of things, and not everything you find is actually going to be malware. You're going to find things that may not be quote unquote evil malware, but you may find people in your environment that are using TeamViewer. They're using TeamViewer to get to their home computer so they can surf porn, play video games, and gamble without the filters in your environment. Now, that's not malware, but is that absolutely something you want to investigate in your system? Absolutely. Absolutely. Or RDP. This is a hospital nearby that got compromised by an open RDP server. Now, the lower left-hand, that's a LAN turtle. However, we have seen people use similar devices, not as a LAN turtle, but as a USB to Ethernet adapter that had micro Linux kernels built into it. We've seen this in healthcare institutions where they use these adapters for devices that don't have Ethernet adapters in them, but they have USB port. They plug them in, they plug in the Ethernet cable to get away from wireless, which is a good job. But then that device has the capability for the manufacturer to remotely manage and access that Ethernet adapter. So that's not an Ethernet adapter, that's a full Linux system. Also Nuance, they're the people that are now behind the Dragon Naturally Speaking software. They have the ability for remotely controlling systems for the purposes of troubleshooting. None of these in and of themselves are malware. All of these are potential attack vectors into your environment. And your organization should be aware of these different types of things that can show up in an environment. Even though they're not malware, they should be investigated. Because what we're looking for is signal to noise ratio. We're looking for beacons that are not matching the connection profile of a normal human being using that computer system. And when we're doing this, one of the things we should do is kill ads. I know for many of you, you're trying to get a job in SOC analyst, but you're all going to move up in the career field. You're going to do awesome, all the amazing places that you'll go in your career. I'm excited to see where that is. But eventually you're going to get into a situation where you have some power and some authority. And people are going to say, what are we going to do to try to protect our environment? And one of the things you should say is, hey, I don't know, let's kill ads, because that would be a good idea. The reason why is ads generate a tremendous amount of noise in your environment, and they also create a lot of network traffic you don't want, And it's also a really good attack vector, especially for nation state level adversaries. So this helps clean that signal to noise ratio up as much as possible. Now, as I mentioned, Rita is free. It is free. It's named after my mom. I saw some people kick out the Darknet Diaries link, the scenes from the Big House, and that Darknet Diaries episode is about my mom. And if you guys want, you can get that link. You can listen to me tell a story to Jack about my mom breaking into a prison. It's a really good story. Don't have a lot of time to get into it. My mom broke into a prison pretending to be a food service technician, or food service health inspector. Now, the other thing about this is this tool is named after her. And my mom helped with the financial side of Black Hills Information Security, and she passed away a number of years ago in 2016 from pancreatic cancer. And the tool isn't named after her because she passed away. She kind of became a surrogate mom for a number of the people that worked at Black Hills Information Security. Even though she was my mom, there was a bunch of people that maybe didn't have great relationships with their parents. And my mom was kind of that surrogate mom for a lot of those people. And some of those developers decided that they wanted to name the tool after her. Now, while my mom was fighting cancer, we would go down to Arizona and we would do Cancer Treatment Centers of America. And I remember she would do cancer treatment. My dad did the vast majority of trips, but every once in a while I went down and I would still do webcasts and still do work. And I would sit out in the hallway at the hotel and I would do my webcasts. And I remember my mom coming out and she sat down next to me. She woke up after a nap after chemo and she talked to the people that are part of the BHIS tribe of businesses, our family, our extended friends, our Discord people, like the people that make up this amazing community. And she talked through what she was going through, how she was dealing with it, answered a lot of questions. And one of the things that she asked is that if we could please keep the tool named after her free. And this tool is free. It's free. Anybody can use it. Put it in the heart of their commercial product as long as they give credit to where it comes from. And it will remain free. We have over 26 patents associated with what Rita does. And we give it out to the community because we think it's super cool. It also does something that no products actually do. So what we're going to do is we're going to jump into another lab here. And we're going to do the Rita AC Hunter lab, which is going to take us again up to and through the break. So we're going to do Rita. This is one of those labs that exists in all my classes. And you can take that a number of ways. One, I think it's that important. Two, it's named after my mom. But you're going to play around with Rita. I would recommend everybody, I know this sounds weird. I would recommend skipping the Rita section and going directly to the AC Hunter section. The reason why is we have changed Rita dramatically in the past year. And if you were to download Rita, nothing above would matter. But what you're going to do is you're going to go to aihosted.com. And when you go to aihosted.com, it's just a hosted version of AC Hunter. There we go. And you're going to log in. Although I think I just remembered this thing doesn't work very well in Edge. Let me go to Chrome proper. I am in Chrome. Oops. Uh-oh. Wonder if they're updating it on me right now. Is it opening for anybody else? Let me try a different browser. Oh my. Hold on. Just give me a second. It's time for me to call customer support. Just give me a moment. We'll do this and we can do this lab like tomorrow, or you guys can do it tonight whenever he gets it bounced. Which is weird. It's the first time we've had any issues with this VM in forever. Ah.
All right, sir.
Hey man, currently in the middle of class. Can you do me a favor? Could you have Bill or Keith bounce training.aihosted.com?
Could I have him do what? Bounce it?
Yeah, bounce training.aihosted.com.
Training. analyst.com. Yep, but we'll get on that.
Thank you much, sir. Appreciate it.
Bye.
All right. That was Chris Brennan. He is the lead course author of all of our network threat hunting and packet analysis classes. And he's also the COO of AC Hunter. So he is currently bouncing the system, and we'll get it up and running here in just a couple of moments. Some people say it's working fine. Is it just not working for me? Is that what's going on? I have an extra H in my URL. How is my extra H in my URL? Yeah, it's right. I mean, it's trying to load it. It's got the background in there. Maybe he fixed it for you guys and not for me. Maybe Chris doesn't like me, actually. All right. Is it working for you guys? Because we can do the lab if it's working for you. If it's me, I'll just clear out my cache. All right. Well, let's do it. No, trust me, it's not too many people hitting it at the same time. But we're going to let Chris bounce it really quick. There we go. So I'll talk about full PCAP, and then you guys can go through the lab. How about you guys go through the lab a little bit later? So we'll give it a chance to do that. All right. So let's go through. Let me try this full path. All right. Well, if it's working for you, I mean, I'm not that important here. I got to be honest. I am very much unnecessary here. Oh, let's see if that works. That is working now. All right. Well, Chris is going to bounce it anyway, so it's probably going to go away. But I'll go ahead. Let's do the lab. All right. So whenever we get into, just teach from memory, totally can. When you first get into AC Hunter, you have to click this little gear to open a data set. At the bottom of the lab, it has a series of questions that it's asking you that are specific to certain data sets. Like, that's weird. Like it'll say check WinLab agent, click confirm. You would load that data set and it'll ask you questions about beacons. So you'd go to the beacons tab and answer the question about WinLab agent. Or another one, you'd go back to the dashboard. Let's say it's asking a question about DNSCAT. Well, you can go down to DNSCAT2, JA3 strobe agent, click confirm, and then look at the DNS data associated with it. No problem, right? So how you get to the data sets is you go dashboard, the gear, and then if it's asking a question about a specific tool like beacon or beacon's fully qualified domain name, you would go to that specific tab to answer that question. So this lab, again, is going to take us up to and through the break. When we get done with the lab, I will walk through and show you the solutions, but there's a series of challenges here in the bottom that it's asking you. All right, so let's get rolling. When we come back, 10 after, I will go through this lab, or let's give it 15 after. Let's give it an extra 5 minutes. So we will resume at quarter after. So I'll see you all in just a little bit. All right, so we're back. Let's go ahead and run through this lab and answer some questions, right? And as we're going through these questions, you know, most people get through the questions in the amount of time that we have for the lab. So keep that in mind that you were answering these questions about these data sets, and you were answering these questions without knowing anything about any crazy level, like doing R tools or data mash or anything like that. So we have WinLab agent data set. What is the connection interval for 10, 10, 98, 30? Awesome. So let's go into the WinLab agent data set. I'm going to select that. I may need to log back in. There we go. Let's go ahead and log in. I'm going to set this because do you remember me? There we go. So we're going to click the gear and we're going to go to the WinLab agent data set, click confirm, and we're just going to go to beacons. And the interval on that, the mode is we have 3,729 connections at 15-second intervals. Holy moly. That's a lot of connections at a really, really super strong heartbeat, right? Now, we also have some of what we call left drift. This is created, left drift or right drift. This is created by our malware developers at BHIS to get around k-means clustering and some of the algorithms that are used for like if somebody's using Splunk or Cisco to bypass beaconing detection, which is enough to get by that. But the big thing also is to look at the bottom. The histogram for this is really super flat, really super flat. That's the number of connections per hour is like 250. I can do it by 30 minutes and so on. Over here on the right-hand side, I don't know if anybody played with this, but if you click the 2, it shows you the data size. And there's 7,168 connections that have 0-byte payloads. Now, this is really important because when we're working with our customers and they have a compromise, a lot of times the attackers will successfully break into an environment, but the malware has not been activated. It's just beaconing back and forth, back and forth, back and forth. I sway with the wind. Resolution slips away again, right through my fingers, straight into my heart, where it's out of reach and it's in the dark, right? So I can look at this and I can tell my customers that they do not have, it's just the malware was installed, but it wasn't activated and no data was exfiltrated from that environment. So that's pretty cool. We got that one. Next one, GCAT dataset. What's the historic fully qualified domain name for the malware? All right, cool. So let's go ahead and let's open up the GCAT dataset. And let's go to Beacon's fully qualified domain name. And on this one, you can see that the fully qualified domain name is gmail.smtp.msa.l.google.com. Ooh, what's that doing? All right, so this is actually a piece of malware that we created the initial proof of concept for a long time ago. We had a theory that, initially I had a theory that people were completely ignoring all traffic that went to Google and private email servers. And my theory was based on the fact that a lot of organizations with GDPR, HIPAA, privacy information, they didn't want to get that data. So a lot of firewalls were just ignoring it. So we created a piece of malware called GCAT, where all of the command and control went through well-formed email messages through Google. Okay. And that worked. And we discovered that almost every firewall on the face of the planet completely ignored any and all traffic to Google. And this makes sense, right? Whether or not it's Google email, whether it's anything. So if we look at XKCD tar, right? XKCD tar, I love this XKCD comic. Comes in, it says, Rob, come quick. You know Unix. Disarm the bomb, simply enter a valid tar command on your first try. No Googling, you have 10 seconds. Rob, I'm so sorry, right? So imagine if every time you did a search for any command, it would generate an alert, you'd have false positives all over the place and people would be like, John's forgetting how to create a tar archive rather than extract a tar archive. And then emails, I don't want to look inside of people's personal emails. I'm just not actually, I've done that in my career. It's never good. Like your private things that you're into, whether it's pies, knitting, anime, weird foot fetishes, are really important to you. I don't care, right? I've never gotten access to someone's computer as part of a forensics investigation. I'm like, oh, this is good stuff, ever. It just never happens, you all. It's just creepy. So no one wants to see that, so it's ignored. Now, this particular backdoor, kind of completing this arc of the story, was actually, this technology was picked up and used by the Russians whenever, this was before the war, whenever they brought down the power grid in Kyiv. So that's kind of not cool, right? All right, the next one, DNS Cat 2 JA 3 strobe dataset. What's the domain for the lookup count? All right. Another way that we get around environments all of the time is we have the ability to use DNS as a command and control. Now, for those of you that don't know, DNS is like the internet phone book, right? If you're trying to look up like what does r-1x.com do, you're going to have to go to the domain server, the kind of the phone book, more that domain to resolve it. So what happens is we set up our command and control because, if it's DNS, it's not DNS, couldn't be a DNS. It's not possible it's DNS. It was DNS, right? That's just what we say, right? So if we look at this particular situation, right? Whenever a DNS backdoor fires, one of the key characteristics is a very high, fully qualified domain name count. And let me give an example on what that is. You go to www.google.com, mail.google.com, maps.google.com. Those are fully qualified domain names all the way down to the host, www, mail, and let's maps, just hitting 3, right? Now, the problem with that is if the malware is doing those fully qualified domain names, it does a random, like fully qualified domain name for that domain for each host. And it does that to force a full recursive lookup all the way through. So you have these really high fully qualified domain name counts whenever people are using DNS backdoors. So you can see in this situation, they have 62,468 fully qualified domain names that resolve to r-1x.com. Number of lookups is 109,227. Those are big numbers, right? If you're looking at that across Google, Google doesn't have 62,000 fully qualified domain names. Amazon doesn't even have that many. But let's say that we have a high number, right? And you're like, well, is it possibly malicious? So if we're looking at these huge numbers, if that was a domain that was being used heavily in the organization, we would see lots of phone book lookups for lots of systems. Okay, well, let's look at that. Only one system's making all of those queries. So one system is making over 60,000 individual fully qualified domain name lookups, 108,000 total queries. But that in and of itself is not a smoking gun. It's not. And the reason why is it may be possible that this organization's domain controller is 192.168.88.2. If that's the case, all of the systems that are doing recursive lookups would forward all their recursive lookups through that system. So this may be normal, but let's take a look at the direct connections. We have one system making all the queries. We have one system making all the connections. That's malware. All right. So when we're looking at this lab, kind of running through this, we were able to do this with the GUI, showing you how to do it and pull this analysis. How long would it take for you to go through and do that by hand with a packet capture? With Wireshark, with TCP dump. I usually say embrace the suck, but there's only so much suck that you can embrace. And that's a lot of suck to embrace. And this tool does it automatically for you. So AC Hunter, if you want to play around with it, we have a lab where you can run it at home. It's the AC Hunter Community Edition lab. And we show you how you can get AC Hunter running at home at no cost. And what it does is you install it on a VM, you install BetterCap on the VM, and then you do ARP cache poisoning with BetterCap to reroute all of the traffic on your system through your AC Hunter system, your Rita system, and you're able to start detecting beacons in your environment at home. Now, this works really well. I know this works really well because I have teenagers and I have a locked cabinet where my teenagers cannot get into to like mess with my network settings because I run ARP cache poisoning and Firewall and all these different security appliances in home. So that's good, right? The bad thing is I've also taught my kids how to pick locks. So that's bad, right? So I've got videos, I've got a little like Nest Cam, and I've got video footage of my son sticking his hand into the rack and trying to unplug the cable of my AC Hunter system. Because he likes to use VPNs because I catch him playing video games in the middle of the night and he can use VPNs to bypass that. But AC Hunter lights VPNs up like a Christmas tree. So pretty cool. All right, so let's close out the slides for this particular section. If we're trying to get to that level analysis, we can do full PCAP analysis. If you can do a full packet capture with TCP dump or Wireshark, you can absolutely run it through Zeek and then do full analysis with tools like Rita and AC Hunter. Easy peasy. This is the basic level analysis that you need to have. Now, when you set this up, you want to make sure that you set it up where it's pre-network address translation. Now, the reason for that is all of your systems on the inside of your environment have RSC 1918 IP addresses. And we want to see those individual IP addresses of those hosts because once it gets past the firewall, all the traffic looks like it's coming from the firewall because of network address translation. Now, there are also dedicated capture devices like Coralite and Gigamon. Beautiful devices. Love these devices. They are expensive, but when you're looking at how much these particular products cost, one of the questions you have to ask is how much is your time worth? If you have to spend literally weeks and months trying to get one of these things up and running or trying to build your own from scratch, maybe better just to pay the money, get the support, and just get it so it's plug and play. And these devices are absolutely, absolutely plug and play. Some additional things we didn't get a chance to talk about that Chris Brenton talks about in his class would be things like user agent strings. Things like user agent strings. People are talking about the future is comic books, which I have right here. Some of those things we show up in the training and in our CTF challenges in the future is. You should check that out if you've got a chance. But user agent strings are a way of a service identifying what it is to a web service or an API service. You can use this to fingerprint what is going on the inside of your environment. We can also fingerprint TLS SSL authenticate like negotiation for encryption. And we do that through the great project that was started at Salesforce and Carl and his team, which is the JA3 and now JA4 project. We can actually do fingerprinting of TLS SSL certificates by looking at the traffic. You can't see what the data is, but you can look at how it's negotiated to come up with an understanding of what that traffic actually is. And ultimately, kind of going back to that signal to noise ratio, we're kind of looking at the long tail analysis. We want to be able to look at those oddities and those anomalies that do not match normal human traffic on an internet. We want to look for those beacons that are not just standard updates and patches. We want to look for something that's kind of falling in between. And that's where we're looking for the beaconing traffic in an environment to try to identify potentially malicious attacks. But this also is in my intro to security class. It's also in my active defense class. And one of the reasons why it's associated with my active defense class is it's an engaged, persistent activity that you have to do again and again and again to help protect your environment. Also has the capability of incorporating deny lists, like whatever threat intel feed that gives you deny lists and bad IP addresses and bad host names and DNS entries. You can incorporate that into AC Hunter and Rita, and it'll automatically correlate the beaconing traffic to see if it's going to malicious and bad neighborhoods online. Finally, yes, you absolutely can install this in Security Onion. I love Doug Burks and what Security Onion solutions are doing, and it absolutely can be incorporated and run on top of a Security Onion stack as well. All right, so we did the lab already. We're done for the day. We're going to be jumping into user entity behavioral analytics. Now, we're going to do that tomorrow. I do need to apologize though. I have a really important meeting coming up with attorneys. Nothing bad, not evil. BHIS is in the process of becoming a benefit corporation because I want to make Black Hills Information Security completely toxic to any investors ever. So if I ever die, the people that take over BHIS, they can't go, well, we're going to make lots of money off of this company. Nope, I'm going to make it investor poison. And a benefit corporation allows me to dictate what the company does. So my wife and I are going to make it exist for the benefit of the employees and the wide security community as a whole. So I've got to get ready for that meeting and get ready for some of the stuff that we have going on there. So I'm going to jump off. But tomorrow we'll do a full Ask Me Anything as well. But I want to say thank you again for an absolutely phenomenal day 2. It was great working with you all, and I'll see you bright and early tomorrow morning. Thanks, everybody.
All right, everyone. Have a good evening. Day 3. Yes, we know. And we will see you tomorrow, and be here tomorrow for bingo. I'll explain it in the morning. All right, Daryl, go ahead and kill it with fire. Have a good night, everyone.